Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 6 different video game cartridges be placed on a shelf? On our previous problem, similar to this, the question was how many ways can 6 different video game cartridges be arranged on a shelf? We're talking about the number of arrangements. Hence, we use there the concept of permutation, even the use of fundamental counting principle, because for permutation, we are talking about arrangements. If we are going to have 1, 2, 3, 4, 5, 6 as our arrangement, it's just tweaking 1 and 2, making 2, 1, 3, 4, 5, and 6. They are of different permutations, so they are counted differently. This time, the concern is just how many ways we can place all 6 video game cartridges on a shelf. We are just simply placing them. So this is all about combination, because in combination, what's make this different from permutation is that for a combination, we do not concern too much with the arrangement, because even if you have 1, 2, 3, 4, 5, 6, just tweaking 2, 1, 3, 4, 5, 6 or any other parts on this arrangement, it's just counted as 1. Yes, the answer to this is just 1, because once you place all 6 cartridges on a shelf in any order, for combination, that's just equal to 1. Let us show here the process of getting 1 here. The formula for combination is NCR, almost similar to the formula of permutation, NPR. The same N, number of placements we have, or 6, that's cartridges, and we are placing all of them on the shelf. So 6 taken 6. Okay, so because we are placing all 6 of them on a shelf. Now for permutation, before, our answer there is different from combination, and we are expecting that we have a lesser or a lower number of combinations than our permutation. We are going to show it later. The formula for the combination is n factorial over, we have here n minus r factorial times r factorial here. This is different because in permutation it's just simply n factorial, then you have here n minus r factorial. We don't have this term of r factorial for our combination. That's what makes it different, and see that it's on denominator, hence we are decreasing the number. Let's try to do it. So you will have here 6 factorial over, you will have here 6 minus 6 factorial, okay, times you will have 6 factorial, which is your r itself. Notice you have 6 minus 6 here, so that's just simply 6 factorial over, that's 0 factorial times 6 factorial here. Now, 0 factorial is a special type of factorial notation. Even if we have n factorial, which is the condensed way of writing the product of 1 to n integers, we have n times n minus 1 times n minus 2. You have dot 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 times 1. This 0 factorial is a special case, because if you're going to try your calculators with that, you'll also have to see some explanations on the internet. 0 factorial is just equal to 1. Okay, so it's not 0 times 1, but it's just equal to 1. Hence, our combination formula here will just be 6 factorial over 6 factorial, to which we don't need any more to expand them, because this is just 6 times 5 times 4 times 3 times 2 times 1, similar to our denominator. So therefore, there's only one combination, as mentioned earlier, by placing all those 6 cartridges on a shelf. No matter the arrangement would be, they're just counted as one combination, because here is just 1 times 6 factorial. Notice that if we have our permutation before, you might want to check the previous video, you will just end here 6 factorial divided by 0 factorial. And we know that 0 factorial is again 1. So we'll have here 6 factorial, which give us the result of 6 times 5 times 4 times 3 times 2 and times 1, which gives us 720 permutations or arrangements. If we talk about permutations, that was in the previous video, 720 permutations or arrangements for those 6 video game cartridges on a shelf. But when you talk about combination, there's only one. That's their difference. This is the answer for this video. There's only one, and that's counting in. Talking about getting the luck of the draw. For all in, subscribe now.